the right foot external rotation or right hip external rotation.
Oh, yes, yeah.
And I was talking about his eyes and things like that, and I was like, have you ever had an head injury or anything? And he was like, no. And I was like, do you wear glasses? He's like, not anymore. What do you mean, not anymore? And he's like, oh, I had laser eye surgery like 10 years ago. Oh, okay. So that prompted me to do the eye screen, and nothing showed up on that,
Okay.
which was getting interesting. And so I just did what you talked about in terms of the positional testing his adductor system, like side lying, hook lying, and then knees together, foot up. Right side was weak. So I was like, okay, well, let's do the all left thing. And Mayo, his right leg in internal rotation across the body as far as he can, hold it into a couple of seconds of isometric. We did like 3 sets of that, retested the hook line position, and the quality went up. Yeah, crazy. But one of the things he has mentioned is that, because I've got him just doing eyes left on a lot, and like slight side bent and right foot internally rotated on a lot of exercises. And he's like, I find it really, really hard to look left, which again, is quite interesting.
It is weird. Yeah, the backup, if you use the shoulder screen, right, for the oculomotor,
yeah,
you can actually, and if that's cleared and you still want to go deeper into that, because again, that's just a screen to see if there's something obvious or not. You can actually do QMAMC on his cervical area. Have him laterally flex, look left, have him rotate, look left, eyes closed, and try to turn him out of and push him out of.
That was from the procedure in the pamphlet text that you've given us. I went through that, and that is what I did. I just went through the shoulder reduction. I weren't sure about going through the neck because I didn't really have a reason to, but I can see about trying it next time.
Yeah, right, and see.
But what we did by going left worked, so let's just work with that instead. And kind of back to that point about how we get across what we're doing. I've got a friend, he's in the army. He had a massive, he got ran over probably 10, 12, maybe longer years ago. And he pretty much had a whole shoulder reconstruction. He like shattered his humerus. He had a pin right down it, pinned into his shoulder.
Wow.
And recently a couple of the pins have come loose. So he's had them taken out. And they shaved some of his AC joint as well, I think. And the doctor said, "Oh, you'll be back to full function now." And I was like,
Wow.
That was yesterday. He had the surgery, and he got told that after the surgery. And I was like, mate, trust me, this isn't the end of the road for you. It might be. Let's hopefully it is, but I would wager that it isn't. And he's like, oh, luckily, he's got a good physio. I'm like, okay, well, if that stops working or pain develops anywhere else, let me know. Because I wager that the physio doesn't know what to do with that.
Yeah, I mean, think about what his brain must think about that, right? The brain had a map, right? Had that somatotopic map of that structure and the neurological governance of it, and the shape and the geometry and the location and all the information that used to come from there, and then that happened. I mean, how disorganized might that be now? Let alone how it trickles over into his trunk, into his neck, right?
Yeah, but since I've known him 2005, 2006 I met him. So what, 15 odd years. Like he's never, when I was in the army and we were doing PT and things, he could never press overhead. Like with his right arm, I think it's his right arm. Yeah, he could never press overhead because of that, because he couldn't get full range of motion out of it because the pins stopped him essentially. So yeah, I can imagine if he is able to get full range of motion back, what's going to happen when the brain goes, well, what do I do with this range? Hang on, control this.
Yeah, probably will not be able to do it, right? And And I'm sure that the physio will get some function back. I'm sure of that. But
they'll do the trap-free raises and external rotations and band work.
Yeah, they'll do that kind of stuff, which will probably help in some sense for sure. I don't want to take that away from that, but I was looking for a quote I got recently. Where is that quote? Might have got rid of it. Oh, here it is. Even the best medical treatment and physical therapy regimen usually leaves the patient with residual functional deficits that require targeted strength and conditioning work.
Yeah.
And that comes out of a medical rehabilitation publication.
Okay.
Right. So even the therapy world knows, right? The question is, when the way they think about it ends, will they accept new ways of thinking about it? Because they think the way they think about it is the only way it can be thought about. This is paradigms, right? This is the problems of paradigms. And when they become dogmas, they constrain your thinking. And, I have to be careful about that. We have to keep pursuing creativity and thinking. What's another way we can think about this? And the more we understand a system, right, the more we can work with it.
Yeah.
And so this is a critical thing. So
I just sent you a picture of the X-ray he sent me.
Oh, let's see if I can find it.
Just sent it in the chat box.
Yeah, I just tried to open it. Huh. Won't let me open it.
That's interesting.
I dragged it to my desktop. I'll just download it.
Yeah.
Oh boy, yeah.
I suppose it's just the limit of the end of your knowledge, isn't it? Like, and that's when you just go, it takes time, and you keep persevering. I think that's what happened with my sports therapist I was working with. I don't go to see him anymore. Stopped getting into, like I said last time I went to see him, he's like, I was on my back, flared up a little bit. Can we have a look? See what's going on. He's like, yeah, cool, jump on the bed, and just started massaging me. I was like, yeah, don't know what to do anymore.
You don't know what to do anymore.
Fine. Tell me.
Yeah, it's okay. Just say, I'm not sure what else to do, and that's okay. You have to be able to say that, because we can't know everything, right? But, can we change the way we think about it? Pain, right? Local symptom always means local approach and local problem. That's a paradigm that's become a dogma.
Yeah.
I think I'll do my next Max Muscle Minute on that.
Yeah, that's a big one.
For sure. So sometimes that's the case, sometimes it's not. Let alone looking at an X-ray like this and thinking about its influence again, not just in the brain and how the brain now perceives that structure and that part of the system, but its influence on central pattern generation. And how that might disrupt, the central pattern generator and the communication, within that, and how that affects his left leg function. And I've been thinking a lot about that lately in terms of how the system perceives and governs its self and its limbs and its extremities and how it moves. And I would say that the lower body, it must have a different way of relating the left and right leg than the arms, right? Because if I lose an arm, my other arm can still work pretty independently. Like my right arm doesn't really take its cues about what to do next from what's happening on the left arm necessarily, right? Unless I'm doing a bilateral reaching thing. But legs, when I'm walking, my left leg is absolutely taking its cues about what to do next based on what the right leg is doing. Mm-hmm. Because if I lose my right leg, the way I have to use my left leg now is totally different.
Yeah.
I can't use my left leg to ambulate with that whole pronation, supination, lift off, heel strike, normal ambulation anymore. I have to switch to an entirely new mode, which is what? Hopping. Mm. That is not the same way that I would normally use my leg. Right. And so, and I'm seeing that, the sideline scissors, right? Hip flexion, contralateral knee extension, knee flexion. I don't know if you remember going through some of the more advanced CPG stuff where I'm perturbing someone's sideline while their right leg is hip flexed and their left leg is hip extended. And then I try to, the scissoring, and then knee flexion on one side while one is knee extending, right? And ankle plantar and dorsey, right? Because those are such complementary motions that they have to work together. It's interesting to see, like, one hip you might have supine or prone or side lying, and when you assess its quality by itself, and the perturbation is primarily directed at that side only, they might be high quality. But when you do a bilateral simultaneous hip abducted, all of a sudden they can't control that, right? The quality drops. Adduction, hip abduction. So this simultaneous use of the system is also an indicator of control quality and governance capabilities. Upper extremity, lower extremity, can they retract on one side and protract on the other and maintain that, right? Can they do that? So I think the upper and lower extremities have another layer of motor governance that's a little different for those sets of extremities. So I'm going to keep reading about that and seeing if I can find some more information on that.
You mean the upper versus lower?
That's correct. Yeah, the way my upper extremities have to coordinate themselves is relatively independent, right? Because I don't walk on my hands. So when I'm walking on my legs, what's happening in one leg in the stance phase is necessarily preparing the other leg to do what it's going to do, right? Which is to swing forward and land and go into its stance phase. So from stance phase to stance phase and everything in between, the governing system is like queuing up the other side. Get ready. This is what we're doing. Get ready. You're going to be doing it next, right? Because if not, you can't ambulate. Yeah. But that's not the case with my arms, my upper extremity. Yeah. And so I wonder about a little deeper motor governing strategy associated with the lower extremity, and that one side it's taking its cues from the other side necessarily, because again, if not, I'm in a totally different attractor state, right? Is what they call that in motor control. Ambulation, running, these are, you get into a stabilized attractor state where you get to a steady state, almost equilibrium mode of functioning, and the legs give each other cues. This is what I'm doing now. Get ready. This is what you have to do next. Okay, I'm ready. You're doing it now. Okay. And our brain is totally relying on that occurring subconsciously. Mostly all in the spinal cord. We're just giving the general instruction of what? Start walking forward.
Yep.
So we give the system this general instruction, and now the system has to go into a specific governing process to do that.
It does remind me of, again, related back to the Gray stuff and the thing we talked about in terms of their idea of gravity kind of controlling that.
Well, it's necessarily, again, giving the system a constraint. Right? It's saying, if you want to move in this gravity field, this is how you're going to have to do it. And so I concur that gravity is the like the axiomatic reference, the most absolute reference for our motor system, in that it's calibrated to that vector, which is vertical to the ground and tangential. And so our motor system, that's what children, I think, they're trying to do, right? They're calibrating to this gravity vector, verticality, right? Okay, this is what I have to be, and this, my weight, and I feel stuff in my arms and legs, and I got to figure out how to coordinate all this, given the fact that everything wants to go down, right, towards the ground. So, okay, that makes sense to me. So I agree. But again, gravity gives us that sense of direction. So directionality feeds into that idea. I have to move what against the gravity vector? Up. Then I have to learn how to do what? Move perpendicularly to the gravity vector. Oh, okay. So you got to know what up and down is. So gravity gives you a sense of upness and downness in direction, and forwardness and backwardness through the perpendicular relationship to gravity. So the brain, the central nervous system, has to calibrate itself to that. And that's the reason. I've been looking for the reason why standing posture. I'm doing a more advanced paper on why we do posture the way we do and why we look at it the way we do. And it's been bugging me about, considering the infinite number of postures we can assume, why do we look at standing? Why is standing posture like the standard for posture analysis? Why isn't it supine or seated or side lying or curled up in the fetal position, right? These are all postures. Why do we do standing? Because standing represents what? That calibration, that relationship against the gravity vector.
You just had a mini brainwave there.
Well, it's number 4 on my list of why, right? Standing posture is historical and traditional. Standing posture gives the ability to view the body from 360 degrees from the practitioner's perspective. Standing posture is common and important starting position for many exercises. And number 4 was, it presents a specific physics problem for the CNS to solve, the maintenance of center of mass over a smaller base of support. But it's also representative of the system's calibration and governance to the gravity vector. Which is related to the first thing. Something along those lines, if that makes sense. right? Because then supine takes that away. So, all right, we're going to put you in a situation where now, when you're lying on a table, you don't have to manage yourself in the same way against the gravity vector as a motor control problem.
It gives us a frame of reference, doesn't it, as well, if there's differences. Ideally, there shouldn't be.
Yeah, that's the great thing about the gravity vector is it's an absolute value, right? I mean, you can't change it. It's there, whether you like it or not. It's not going anywhere. It's not changing today or tomorrow. A couple minutes from now, it's the same. Same direction, same influence. You have to learn how to deal with it. It's absolute in that sense.
Crazy world. Yeah. A mic drop there.
How do you deal with gravity?
I can understand then why it's the starting point for. Should it be the starting point, or is it just kind of naturally where it leads us for most assessments? Let's just have a look at you standing up first. Do some measurements.
Yeah, because again, there's something basic about standing, right? Because people who can't stand, what do we spend a lot of time trying to help them do?
Stand there.
And if they can't stand and move around, because standing is necessary for ambulation, right? In a sense.
Yeah.
Then we have to accommodate the environment to them.
Also gives a bit more credence to the, I suppose, the idea of the body being set up to get the brain to function, to get your body moving.
It circles back to that thing, right? Again, of what do we got to do? We have to move. Where? In our environment. Where's our environment? Oh, it's in a gravity field. Oh. What are the potentials and constraints? What does the gravity field do for us? Why is it so beneficial? Because, you know, they keep showing that is the primary problem with space travel, right? Is the degradation of our systems in non-gravity environments.
Yeah.
We degrade pretty fast. Deep into the cellular level, right? At the cellular level, we're degrading.
It's like, do you think then that gravity as a I suppose force, or in its ability to create force, is a key reason as to why we've developed into the way we have, and why life potentially isn't developing on other planets, countries, other planets?
Yeah,
we know of.
Yeah, I absolutely.
Like force's relationship to making things change is pretty interesting to me anyway, like in terms of how, if you apply a given force over and over again, the bone can change, the tendons change, the muscle change, the body changes to support that force on the body.
Yes.
Yeah.
Absolutely. So it's a very interesting thing, why we move the way we do. Do you think creatures of the sea are subject to gravity?
No.
And how do they ambulate? How do they move? They have a totally different physical body structure than we do to move in that environment.
You know, they're given up with legs, and I imagine they did have at one point, or the other way around, I know there's a I watched it the other day on like a David Attenborough Blue Planet documentary thing about fish, a species of fish, pretty much giving up swimming because they're quite a poor swimmer. They've taken to this like rocks and land, and they just chew on the algae, and the waves that crash up onto the rocks, that's how they breathe. They just roll around in the damp water and the splashes that they get off that, because their survivability is higher up there, so than it is in the water. It's interesting how they adapt. They've gone, yep, we're shit in the sea, we suck in here. Let's take our chances on land and see what happens. It'd be interesting to see if like, obviously we're never going to be able to, but in 1,000 years or 1,000,000 years or whatever it is, if the planet's still here, if those fish grow legs and turn into lizards.
That's pretty crazy, right?
That'd be a time travel piece.
Yeah, well, why would you leave the environment? Yeah, why would you leave your environment?
If you're not flourishing in it, then survivability is a
But that's the thing though. So if you go to the next environment, but you're not prepared for it, you'll die there. Just like, I mean, how many humans, for how long would we have to send them into non-gravity fields before we'd see evolutionary adaptations, or, something we've never seen, which is speciation, right? I mean, we've never seen one species turn into another kind, into a different kind, right? That's the problem with evolutionary theory. But adaptation is an interesting thing. Why do you think babies even bother trying to stand and walk? Just because they see other humans doing it? Why not just stay crawling around on the ground?
Could you put like feral children in that category? Like you take them out of the environment that, in quote marks, they should be in, put them into a wilderness environment where they're kind of raised by bears, and they end up adapting their behavior.
Would they walk around on all fours? I've never seen a feral child case study where they, were doing that, but most feral children case studies I have seen, they're standing.
Yeah. That'd be it's not going to happen within our lifetime, but it'd be an interesting one if we manage to invent time travel within ours. Yeah, let's go forward 2 million years and check out those fish then, see if they've adapted.
Well, they've had a long time to adapt in the ocean, haven't they? And they're adapted, right? It's incredible. But the way they move is totally different than the way we move.
Yeah.
So the gravitational field gives us an opportunity for spatio-temporal tuning, calibration, right? Because our sensory system experiences the gravity vector. Then the question is, what's the impulse to move against it versus just succumb to it and stay pressed to the ground? Again, that mobility thing, right? We just move around better, given our geometries and our kinetic and kinematic structures and how we're built, and staying pressed to the ground doesn't help us from a survival perspective.
No. Yeah, I suppose at that point it's kind of it's easy to say, it's easy to conclude about the being set up to move. If we don't move, that it's a survivability problem, so the brain's got to trigger a set of mechanisms to get you moving, whether that be pain or discomfort or whatever it is. or hunger cues.
Yep.
It's what has stuck with me is what you said last week or the week before, whatever it was. The brain not seeing the body the way we see it. That stuck with me a bit. I'm trying to picture how the brain might see the body. I don't know if that's possible for our minds to comprehend, to put that picture together. I see it kind of like this central rod just going through the brain, and it's just spinning out everything around it in more dimensions that we can fathom and understand.
Yes, it has to be that way. Yeah, the way the brain perceives itself and the material system it's embedded in, right? So somehow it's aware of itself and what it's embedded in. It knows about your toe, your foot, your right hand, right? Just the simple movements you're doing now, right? It somehow knows distance, calibrates itself so that when you go to itch yourself, you don't punch yourself in the face, right? It must create already in advance. It's highly predictive because of that. So it has direction, distance, time, all encoded within it. And disruptions in that show up as motor output errors. And so we have two ways of thinking about detecting an error. We have normative values that we see, right? See, oh, well, you're of the same species as these other creatures, and the vast majority of them stand up and walk forward. Right? And when they do that, their arms swing and their legs swing, generally in a bilaterally symmetrical way, and so we go, okay, there's that normative. So we can watch an individual and compare them to that normative, but then say there's an error because there's a difference that's highly detectable. But then there's the intra-individual error detection, which is I wanted to scratch my right eyebrow, but I ended up scratching my nose. I didn't want to do that, but I did. And so there's an intra-individual error, right? Which is what we're trying to pick up with the QMAMC in a sense, right? Like, this is what I want you to do. I have this expectation about what you do, and you want to do it too. You tell me, did you do what you wanted to do? And then the person tells you, no, that's not, I wanted to move my leg that way and keep it there, but I couldn't. Oh, error. Against our expectation on our practitioner side of, well, we're expecting you a priori and against normative information that when your muscles contract, they should contract within a certain period of time and a certain rate, right? And reach a certain level of tension and produce torque. And then you should be able to create some equilibrium. That's my expectation. And so then we reconcile these two things. That's where qualitativeness, comes in. Because we can't get quantitative information about that entire event from the client, from the subject. We can't put all these measuring instruments inside of them, let alone inside of us, so we can see that. I wanted to produce 14.26 pounds of torque. Oh, okay. And that was based on my muscle system producing 42 pounds of force as a resultant, right? We can't measure any of that stuff. And that's because of the force angle, right? Right. So we get back to where we can observe, which is useful.
Have you ever utilized any like very basic tests. Can you touch your nose? Can you touch your ears?
Oh
Do
yeah.
you know where these things are? It's that kind of field sobriety test, isn't it? You know something's wrong if they can't do these basic things.
That's it. That field sobriety test is a normative reference process, right? And you know, they can give you what? A breathalyzer, which is a quantified number, right? Which has error in it, but still. But if you fail both, now you're in trouble, right? So.
And what was the second? You said there was 2 ways. Did you talk about that one?
2 ways of determining error.
Yeah, I think so. You said like the normative.
Yeah,
value.
that's the external normative, what other people do, right? And how they behave and what their outputs look like as a larger population sample of interspecies behavior. And then the intra, which is asking the client, what do you want to do? I want to stand up from a seated position. Okay. And then they go try to do it and they can't. And then you ask them, well, what happened? I don't know. I wanted to do this motor behavior this certain way, but I couldn't. Oh, that's an error, right? Because in their brain, they had to pre-construct it and go, okay, and I'm going to pre-construct what I want and make it predictive in my system, and then I'm going to execute. And so their actual execution is assessed against what they built in their head or what they predicted they wanted to do.
Yeah.
And the question is, are they aware of their own error? And we have to ask them. They're the only ones that can tell us.
Makes sense. That makes a lot of sense.
All right. That was fun.
Definitely. Did you by chance record the last call we did?